Ying-Tsu is part of our leadership team for Innovate Bio. And one reason they were brought on board, besides many reasons, besides being one of the lead organizations in North Carolina, I can't talk on Saturdays, in North California for working with high schools, is that they also have Bioscope, which is a supply chain initiative for producing products at the two-year schools, several two-year schools, and supplying high schools. So anyway, this is just one of the many things they do. So Ying-Tsu, take it away. And thank you for joining us.
Yeah, thanks for that. You guys might all be waiting for Nick Cap, but he all of a sudden had a larger workload because one of his adjuncts quit teaching. So he had to take over his classes. And so he asked me to take on this session. So thanks for having me. I'm going to talk today about Bioscope, a project that we have at the California community colleges. And I actually have two different jobs. I don't do much of one job anymore, which is adjunct at City College of San Francisco. I do projects with them still. But I'm mainly at BABEC, which is a 25-year-old nonprofit. And I'm going to talk a little bit more about that too. But I'm calling this a project to build a supply chain of products and students for biotechnology education. Okay, so just to take you through what I'm going to talk about, you probably have no idea who BABEC is. So I'll tell you a little bit about us and supply chain management and Bioscope, as well as how it's implemented. And I'm going to end the session with a new project that I'm working with Innovate Bio, as well as the California Director of Life Science and Biotechnology. So that's a pretty interesting project as well. So BABEC is a 25-year-old nonprofit, and we do four main things. We are mainly teacher professional development. So we train teachers in biotech education. These are mostly high school teachers, also, although we do get quite a few community college teachers that come and do our workshops. Right now we have swiveled and are teaching things online. But this picture really shows you what we usually do. We are in class. It's taught by usually a high school teacher. We have 3 in our team, and they all do hands-on. We also provide modular equipment kits. So for example, I saw that ISO are providing kits, but they don't have equipment. So this is something else we do. So you can have a couple of bins for transformation, for example, where it has the water bath, incubator, pipettes, if that's the case, that's what you want. We also provide curricula, which is aimed at general biology, although biotech teachers also use it. And I think even some community college teachers use it. And our resources are very, very supportive in that we have even lesson plans, so minute by minute lesson plans, as well as slides. So, you know, in many ways, we are very similar to BioRad, except that we do a lot of teacher assistance and teacher help support. We are also a little manufacturing company. So you guys were talking about different fluorescent colors you may use. Well, we have all those. And not to mention, we have ones that are constitutive, which is very popular amongst the general biology teachers. And then the inducible plasmids for color, which are more popular amongst the biotech and AP bio and community college teachers. So please stop me at any time if you have any questions. So BABEC is interesting. We kind of died for a little bit. And then when I came on board 5 years ago, the executive director, many of you may know, is Kristen Walslegel. She came on board 4 months before I did, and we really tried to revive it. And the importance is that this was really started out by teachers, and they wanted to teach the students biotech. And so what has evolved really with BABEC is that we've now become the bridge between the high schools and the community college. Our constituents are quite a few. We work with over 200 teachers in over 90 schools, mainly in the Bay Area. And we make about over 1,000 biotech kits, which affect about 33,000 student experiences. And we say experiences because some students experience with our kits more than once. So some teachers may do 5 of our lessons per year. So that's quite a few. And our aim right now, our mission is to, you know, give access to all the students. So that's why we go to general biology. General biology, every kid has to take that. And so every kid then gets access to doing something fun, something that they may like, you know, and something they may think about as a future career. So what's our reach? You know, our name is Bay Area. Normally, we work in mostly California and the Bay Area, as far north as Calistoga, as far south as Monterey, and this is just a map of what it looks like. We are located in the City College of San Francisco. They're kind enough to give us some lab space, but we also have an office now in a city called Redwood City, which is down in this peninsula here. I'm located actually in the East Bay. So during the pandemic, I'm at my home in the East Bay in Contra Costa County. And we work with all these different counties. So sometimes there's quite a bit of driving for us. But now we have expanded our reach, and in partnership with Innovate Bio and with all the different leadership teams, we're expanding nationwide. And it was evident by the summer series when we also taught some of our courses with the summer series with Innovate Bio. And from that, actually, we have gotten some teachers from other parts of the nation that come to our monthly workshops. So that's been really neat to see and hear that what other teachers in the nation are doing. And we're sort of expanding and opening our eyes some more. So I'm going to continue on and talk about supply chain management. So Nick told me, oh, can you talk about supply chain management? And I'm going, okay, I do supply chain, but I'm not really the expert on this. So I'm going to give a little bit of a background, and maybe you guys all know what this is. And I think we all know a little bit about what this is. So to me, supply chain management is really about this chain of events that happen in trying to create a product. So it's a network between the company, some suppliers, and to produce something, and then finally to distribute. So distribution here is also logistics, right? And within each part of this, there's also a bunch of details that go into it, right? So with raw materials, you want to make sure that it's pure. The supplier has to make sure that it's, labeled properly. I know Jim talked about labeling correctly. That was really important. In manufacturing, we all know what's happening there. We've been hearing a lot about cold distribution, and in having to distribute the cold vaccines in the planes, and then now what's going to happen in the trucks, or how are we going to get to places? And then finally, who are the customers and then the consumers? So this is the supply chain. And many people think about supply chains in other ways. And I don't think any of them are wrong. So you can make a supply chain for anything. And I want to finish up at the end on how we can make a supply chain of students. So the management, though, is managing all those different things that are coming in. So let's say that you're trying to make a product. So you have to think about who your suppliers are going to be that are going to make this product. My son currently is he's a packaging engineer. He's interning with Amgen. And so he's talking with suppliers and what they can supply for the packaging that he's trying to make for Amgen. So he's interested in medical packaging, which is a huge field, by the way. So, he's talking with suppliers all the time and then he also works with the manufacturing part as well. So that's kind of interesting to hear him say these words that I'm kind of used to hearing and talking about these days.
So is he interning down in Thousand Oaks at their headquarters?
He's interning mostly at home or at his apartment he goes to Cal Poly San Luis Obispo. Okay. He did go into the lab and Amgen, I think a couple of weeks ago. And he also has to go into the San Jose location, but right now everything is shut down, so he can't go in. It's been interesting, I think, in many ways for him. And I'm very proud of him because he's been able to really talk with suppliers and even people from Europe to understand what their supplies are. So it's kind of an interesting process, and he's paid really well. So, any other questions here? So we talked a lot about vaccine from Dennis's talk, which was awesome. And during his talk, I was thinking about supply chain and how it relates. And so I was able to find this little cartoon about that. you know, we had a chat going on about glass vials. So imagine having to have that supply for glass vials, and then having the raw materials and equipment for filling and labeling and packaging, all those different things that go into the manufacturing process. And then finally having to warehouse them, the freezer supplies, as well as other things, and then where it's going to go in hospitals and clinics. And then finally, the consumers, us, you know, the health workers first, responders, immunocompromised folks, and then finally for us. So just in thinking about all the processes that we talked about today, you know, has a little bit of a supply chain within a supply chain. So it's kind of a fun thing to think about. So then I'm going to talk about next is Bioscope, and this is what we call our Northern California supply chain project. So this project has been around for about 5 years now. We always keep calling it a pilot project. It is, and you can see the logo there. It's manufactured and analyzed by students for students. And I like to think of this as students making products for other students, high school students, community college students, and even from nonprofits. In many ways, you know, the students are making products for BABEC. And Katie Krolakowski's at Contra Costa College, she's doing some analysis for a nonprofit in soil microbiome. At Merritt College, where they do a lot of microscopy, they're making slides for all their students. So, you know, if you have a project like that, you know, just think about how you could be using it for your own students or for your high school partners to try to make some real products that are going to go out and be used. This project is funded by the California Community Colleges Chancellor's Office. So if I didn't give them a big acknowledgement, then it would be sorry for my part, because they have given us quite a bit of funding to do this project. And we are now funded by the NSF ATE grant, the Advanced Technical Education Grant, for mostly with Laney and Skyline Colleges to continue this Bioscope project in some other ways as well. And also, Innovate Bio is helping fund a supply chain standardization project, which I will talk about at the very end. So some objectives that we have here for Bioscope. It's to provide work-based skills for students, of course, by simulating a workplace environment. So what we like to think of this as sort of like a pre-internship. So you're simulating this workplace environment in your classroom. And I know many of you do that. This is nothing new. Our focus, though, is a lot on QC/QA. In the state of California, our middle skills report really pointed to the need for students that know about quality control, quality assurance. And the state of California, Terry Quenzer, Life Science and Biotech Director, had funding for the faculty to learn more about quality, FDA quality, and also even take the test for CQIA. So for us, that quality idea has to run through the systems that we are building, the documents that we're making, the curricula that we are teaching. So that's a huge part of us. The other objective for Bioscope is to provide awareness of the biotechnology field by providing these low-cost products. So these high schools, you know, some of their, in California especially, there's so many barriers, and especially in underserved populations, schools in those districts where they don't have a lot of money. So what we're providing here are low-cost products that they can use. And what we are also seeing is that there's a huge payoff for the students, the community college students that are making these products, because they're so excited about biotech and they want to, you know, pass on that excitement. And so they want to see the high school students using these products in their classroom. And so in this way, we're trying to increase the diversity of STEM and diversity of biotech, which we all know is much needed. And so we want to, we are the bridge, or we feel that we're the bridge to provide sort of this idea from high school to community college. In California, there's a lot of this disconnect. There's not a lot of talk. And I'm just talking about in general. I think Jim probably has good relationships with the high schools around where he is, but we're trying to build more of that, because enrollment at our biotech programs in Bay Area are low. And we can't just rely on these for your grads that are coming back anymore. You know, we got to rely on trying to build enrollment in different ways. So some of the outcomes then are technical and professional skills for the workforce or transfer in STEM. So that's what we want to see. We have milestones that we have to fulfill, especially with the state of California. I will say that the Bioscope project, the objective was not in trying to create a guideline. You know, that's a bigger project that luckily NSF is going to help fund, because, you know, our thinking is that it's a year by year grant, and we just want to create these or have these outcomes that are much more quicker, you know, students getting jobs or teachers writing curricula for it. So, you know, the Innovate Bio is going to help then create these much more these guidelines that can be scaled up in throughout the nation. That's our aim for the supply chain in any case. Oh, this is weird. It's coming out strange. Okay. So, you know, I first started out with that sort of flow chart for supply chain management. And I just wanted to recreate this using sort of what we do in Bioscope. So what we do is that we get these orders from high schools and colleges, and then we go to these manufacturing companies, Laney, Skyline, City College, all these different ones. And then the students, the technicians then are making these products. They're supplied to us, the customer. BABEC is the customer. Here I am in my blue car. And then I'm delivering this to our high school teachers, who are then using it with their students, so they're consumers. So, you know, this is our supply chain, basically. Learning and assessments. Yep. Okay. So these are just some pictures for what's happening in a classroom. And this one, I think, is from Laney College. So Doug Bruce, and I want to just always give acknowledgement to Doug Bruce and Nick Kapper. Just great to work with in terms of this project. And so we have simulated work environments at the college itself where they're producing useful products. So they're not making something and dumping it down the drain. They're making something that's going to be, you know, used. And what's happening is that students are, we're finding from assessments is that they're much more careful and much more engaged in what they're doing, because they want to make it right. They want to make sure that it works. It allows them to have a lot of hands-on practices and to work collaboratively. You know, for biomanufacturing, you guys all know this. It's document, document, document. You cannot have enough documents and SOPs. So that's something that they do. As you can see, this young woman's writing down notes. And then the other part too is that, you know, sometimes we think of, you know, biomanufacturing where you have SOPs already. But I think that when you are in a situation at school, when you're trying to manufacture something, someone steps up and thinks about workflow. So there's still a critical thinking process to that in trying to improve workflow or trying to improve the process. So, you know, maybe in industry, you can't do that, but I'm sure in a classroom you can, you know, so they are learning some critical thinking skills and learning to do things better. You know, it's this process improvement, a quality improvement that we always try to instill amongst our students. You know, a huge part of that, again, is quality control, assurance, management, by introducing things like kappas and fishbones. So if things don't work out, you know, why doesn't it work? And going through that process with your students. So that's another analytical, critical thinking skill that you can inject into your biomanufacturing. So here we go. Here are some validation and quality that they're doing here. So here they're trying to, upper right, top right, is they're trying to validate their autoclave to make sure it's working properly. In the middle here is some plasmid preps that City College and Bob Del Vecchio had made for us. And he uses an ELN. I don't know if you can see it. It's kind of faint, but they use Benchling, and I'm able to access their Benchling batch records and look to see that their quality is good. Down here on the bottom left are the students in Nick Cap's advanced biotech class, and these are quality assurance agents. And look how serious they look, right? That's the way they are, quality assurance people. In the bottom right here is the Laney student who's doing some QC of the plates, I think, that they poured for us. So, you know, all these different steps always end with some kind of a quality check. So, and then if things don't work out, we have to go back to the fishbone and see why it didn't work out. So just some examples of some of the products that they make. They're buffers. When you're first teaching your students how to make solutions, why not make solutions for your other biology classes? If they're doing transformation, do some calcium chloride for them. And you can see that it's labeled. And I remember Jim saying labeling is very important. So something that they have to do, that they learn how to do. And it's also kind of fun for students, I think, to learn how to label. Here you have a Skyline logo, and students make a logo every single semester, something that's different. On the right part here, Nick Cap really likes packaging. So he figured out a way to have these cardboard cutouts for these tubes of Chelex that are aliquoted out. And these Chelex tubes are for DNA extraction. From BABEC's customers, our customers, the high school teachers, we were finding out they weren't extracting DNA properly. And so we thought maybe they weren't aliquoting the Chelex beads properly. And so some of the students are aliquoting from us. And they're learning pretty simple things, but like aliquoting beads at a correct volume, that's all pretty important. And sorry, that's a phone. So they're learning how to aliquot, but then they're doing a check. In this case, it's probably a visual check to make sure the beads are in there and of the correct volume. So that's just some of the projects here that you see. Middle here are plasmids that were made from us from City College. So what are some of the outcomes here? So we've had throughout the years over 200 student participants, and I say the commercial cost priceless. Total hours spent on these projects, and the number, the dollar calculation is from $18 an hour. They make a lot, bacterial transformation is like the genetic engineering biotech curriculum in the high schools. So a lot of agar plates are poured and needed. I mean, in our own lab, we just go through it sometimes and just pour plates like crazy. Some of these items are actually not sold. Chelex tubes, agar bottles, lysis buffer vials, there's no equivalent. Plasmids that are made for us are in the 50,000 range. And of course, then we have these high school students that are served, over 17,000, and that's priceless. The ability to actually do some hands-on science and learn about biotech and learn about genetic engineering. At least to us, I feel is that we're at least getting them a glimpse of what, doing some lab bench science is all about. And a lot of the sort of the assessments that we have done too is that they understand that, like, oh, they can do this. It's not something that's scary. It's something that's fun. And what we do too in the Bay Area is that we also bring in the community college to talk about their project, their program, and try to change the minds of some of the students that to consider taking biotech at the high school. I mean, at the community college. So I want to switch a little bit to talk about life during the pandemic. We all know how difficult it is, especially in California, where we are now back in shelter in place. I think it starts midnight or something for my county. And so what it means is that all the colleges are closed. Nick Cap really got his administration to allow him to be there on Fridays with his students. And Doug Bruce also finagle a way to get some of his students to be on campus, but this is recorded, so hopefully no administrators hear that. So for the pandemic take-home COVID project is a project that I did. So we also got funding from the state of California to do something that was hands-on for students. So as also the chief scientific officer at BABEC, I developed this kit where students could be learning to do some ELISA, but also to do some point of care testing at home. So this has been this huge project for me in my lifetime, and created these take-home kits for COVID testing. And the idea is that these aren't real, right? They're not testing for COVID. These are mock tests. But the idea is to have students learn about what the diagnostic tests are. We hear a lot about the PCR, the ELISA, the rapid test. PCR, we can't do so easily at home. So I'm developing that for when we go back to the classroom. But we can do ELISA, and we can do point of care or rapid testing. So that's what this test is all about. And you can see some of the items that are in the kit itself. 96 well plate. And I know Joanne talked about supply chain. So it took me 8 weeks to get them. I'm sorry, industry. I asked for 1,000 plates. And also some other things that were hard to get, like gloves was hard to get as well. I waited a long time to get those. And then an interesting story are our point of care tests, which are the lateral flow assays, otherwise known as, or rabbit test, paper strip test. You all hear about the different types, what it's called. And I can tell a little bit about the secret behind that, if you want to know. So yesterday there was a session at Skyline that I couldn't attend because I'm under quarantine. My kid actually caught COVID. He's fine, but I wanted to make sure that my husband and I were also fine. We got tested, we were negative, but I was still under quarantine. So I couldn't go into Skyline to take pictures of the students doing some kitting for me. And you guys may or may not know that kitting is an actual job title. So kitting can be an operator or they can be a manager. And to be a kidder, you should be really detail oriented and really understand the whole packaging and labeling and efficient way of putting things into a kit, which I was as well for this project. And it happens that BABEC has another staff member whose name is Kitty. So Kitty was helping do the kitting at Skyline. So this is a video that Nick fixed up for me last night, and I just want to show you. It's in fast forward time, and it's following this kid here, Ryan, taking him through the process of doing the kitting. And you can see that they're all trying to do some social distancing. They have PPE on, gloves, and a mask. And we've been doing these Bioscope projects every Friday now this semester, which has been awesome for the students. And they've been coming in and logging in their time and really learning to do some hands-on work while everybody else is locked down in their home. So let me do this video real quick. There's no sound because it was sounding funny, so I removed it. So this is kind of what happened yesterday at Skyline College, and just taking them through the process of manufacturing something or kitting something, which I thought was pretty funny and hilarious when he sent it to me. So how do we check for quality here? So something that they did, and Nick always has these great ideas. Well, we can check it this way. So he's like I just love the way that he thinks about how to implement quality checks, because I'm like, I don't know how to check for quality, but he weighs them. So these are all weights, and then getting the average. So they made 60 kits yesterday, and these are the average weight of the 60 kits. I believe they also went through a CAPA to see how they can, how the packages could be better. These are small packages. They're about 6 by 4 by 2, I think it is. And so it really fits in quite tightly. And some of the times they bulge, and I don't want the bulge. I said that you got to have no bulge. So they try to fix that so that it doesn't have a bulge. And it means removing air from some of the bags mainly. Any questions so far? Okay, so I'm going to move on and see how you can do a supply chain in your classroom as well. So there's different ways that we've been doing supply chain, and it really depends on what the teachers can and can't do with administration, with what the course outline is like. I think the best way of doing this is in class. You're putting it as a module in your course sequence. It could be even a whole class. Ohlone College was really the first college to have a class on supply chain. So it allows for all students to take part. and you have this teamwork that needs to be worked out. Here it's Skyline again, and they're trying to weigh out bottles so that you're making these LB agar bottles. And when I was there taking pictures, one student stepped up and took the lead in saying, okay, the tables need to be like this. We need to put the scale here, and then we need to have water here, and then we need to have a process where, how are we going to check each other to make sure it's verified? So, a lot of ways that the way that the teachers, the instructors allow the students to take part in thinking about what the best flow is, what the best process is, really helps them in I think being out in the workforce and thinking for themselves. So they're doing some assessments as well, and you can see everyone's participating in some way because everybody has to make them. There's also another way where it's a drop-in club, just like Nick's class is a drop-in club. Lainey has a drop-in club as well as in class. Here we have a student that we actually hired, Giselle on the left, who is training other people how to pipette. So now you're having some kind of mentee leadership going on or training going on by the students with another student. So now you're creating yet again another layer of sort of this thinking and leadership and supervising, and that I think it's just so important for students to have those skills when they go into the workforce and really to try to get more higher pay, right? It's a supervisory work that you're going to get the higher pay. So this student ended up transferring to San Francisco State. She was great. So, the loop that needs to close, though, is this bringing in these products that community colleges are making into the high school so that they are jazzed up about biotech. This is a high school in San Francisco where they're doing, of course, bacterial transformation. And I love that kitting idea that the ISO has brought up to make kits for high schools and having the students figure out what to do, because that's what BABEC does, is that we have kits for bacterial transformation. And then so actually we could audit your students, ISO, if you want us to. But here the students are excited about seeing their results and actually doing some hands-on science in the classroom. And our kits are very similar to BioRads, just a lot cheaper. So I wanted to stop here because I've been talking a lot. And so any questions from the audience, or I have questions for you if you don't have questions for me.
I have to admit that I really like the idea that your students could audit. That's like another job function. That's a much higher level job function.
Yeah, the initial idea was for, like I go in to quote unquote audit. I'm supposed to be the main auditor with my clipboard and look really serious, but it doesn't usually happen that way. I'm usually talking to them and asking them if they're having fun or how they're liking things, what they're learning, I'm not a very good auditor. Okay, so if I don't have questions, then I'm going to ask you guys questions. Do you work on any projects that's similar to Bioscope or supply chain? Are you producing something like plasmids, for example, right? Do you produce something that you could be using for the next semester or for your other colleagues? Anybody out there doing that?
Hi, Ying-Tsu.
But
Yes,
I'm
I
sorry,
do.
Jan, go ahead. And you
Hi,
already know.
Ying-Tsu. This is Jan from Shoreline. And we've chatted a couple times, but Shoreline runs a kit program, and we are doing some of these things, but not in as nice of an organized way as you're doing it. Students in the biotech classes have produced plasmids for me to use in the kits and other types of solutions. Competent cells, which is great because those take a long time to make, so it saves me a ton of time if the students make them as part of one of their classes. But I'd really like to. I'm really interested in how you do this, and I'd like to change how we do it at Shoreline and make it a little bit more organized, et cetera. So I really appreciate your presentation.
Yeah, thanks. Maybe you can be one of our first scale up nationwide.
Yeah, let's talk.
Yeah. So let's see. And the other question I have for you guys too, I think most of you or all of you are community college teachers. Do you have close ties with one or more high schools that you've worked with to try to entice enrollment into your colleges? And I don't know what your enrollment's like, but I know where I am, this colleges around where we are, we do have problems with enrollment.
And I mentioned we have, this is Mindy Wilson from Lansing Community College. We have ties with our intermediate school district where they have it's called a Bioscience careers program. And we kind of create a pipeline from there to LCC. I also wanted to mention the first question you had. We have a course where they use the NBC2 manual for Pichia pastoris, and the students, they're not making a kit, but they're using that system to learn. They're divided up in different, they create a company and they're divided up into different groups. There's a quality control group, a production group, quality assurance, SOPs, production, and all that. And so they design SOPs, quality control procedures, production procedures using the Pichia pastoris system, where it's the yeast cell that makes the human serum albumin, and then it's induced with methanol. And so they look at different parameters, run gels, play with methanol concentrations, look at production and all that. So it's not producing a final product of a kit, but it is simulating GMP and GLP and all that. So.
Yeah, for us, they don't necessarily make the whole kit like ISO's class does. They make parts of kits. So they may be making the buffer or doing the, aliquots or things like that. So they don't necessarily, I think the whole kit thing is awesome, and it'll take a lot more work on the part of the instructors too. So, in many ways, like to adapt it, we don't, to adapt it is as easy as making buffers for us and how we see it, at least. And it's nice to hear from you, Mindy. Is it Mindy? Yeah. I actually got my teaching legs from Lansing Community College. I went to Michigan State to do my postdoc, so it's nice to see some Michiganders here.
Yeah, I actually remember Ralph mentioning you, and I think he gave me your lecture notes for cell biology.
Oh my gosh.
I still might have them somewhere.
This is a small world.
That was about 15, 17 years ago.
Yeah, that's right. That's
Yeah.
exactly right.
Yeah.
So, yeah, this is so nice to meet you here.
Ying-Tsu, there are a couple
Angela
questions.
from Kansas City. We have in our area 3 large high school programs and partnerships. At Johnson County Community College, Dr. Heather Seitz is working to, we have what's called College Now, which would allow us to accept transfer credit from the area intro to bio classes and other College Now life sciences classes that they're taking. So they're developing that partnership. In Shawnee Mission School District, they have a very large careers pathway program. And I think last time I checked the participants, Zulma Perez, who is one of 2 instructors in their biotechnology program, is in attendance here today. And then in Kansas City, Kansas, we have probably the largest of the programs, which is called BioPlus. It's the Kansas City, Kansas Biotechnology Training Laboratory. And that's a partnership with one of the larger districts in the area, the Kansas City, Kansas School District. They bus those students in from 4 different high schools for 2 hours a day of training at the KCK BTL.
Great. I think we might talk with you sometime because there's also another project with Innovate Bio to think about these high school pathways. So all relevant right,
Yeah, reach
Linnea?
out anytime. I can put you in
Yeah.
contact with all of those instructors.
Great. That's good to know.
Very relevant.
Yeah. Anybody else? Or Ponima?
We have 1 minute to go, and then we are going to break for 15 minutes, and we reconvene at the time I posted on the chat for our next session with Bridget Kirkpatrick.
Can I go a little over?
Yeah.
Maybe I'll
Yeah, sure.
yeah, let me go over a little bit. So, Bioscope was about that. So as it turns out, there's a lot of differences with different supply chain projects. So there's different products you can make, different customers. There's also different ways that you can implement, and different high school partners that can create this, to try to create this supply. So I wanted to point out that we are working with Terry Quinzer and Heather Holmes from the Southern Cal folks. So the North and South are going to get together and talk about supply chain and come up with some guidelines. I think standardization is maybe too harsh of a word. So some guidelines in how you can do the supply chain. First of all, we're going to pilot in California after the guidelines are written, and then scale up. So this is my picture of the North and South getting together. And we're going to first have a task force and advisory group from industry as well as faculty, current practitioners. And in California, supply chain is huge, apparently. I didn't even know about the South until they told me. And so we have some faculty practitioners that are practicing supply chain. We'll have some new faculty in this task force. And then we're going to probably pilot with 4 different schools, hopefully when we can go back in May or June. And some of our outputs are having some task force and advisory, draft some guidelines, train others, and we'll pilot in California to finalize those guidelines, and then finally scale to other states. So, we always talk about this pipeline of students that we want to have, right? And I like to think of it now as a supply chain of students. And this is not my idea. It's really Terry Quinzer's. With BABEC, what we do is we train teachers so that they can teach biotech and gain the confidence as well as the knowledge to teach biotech. Because for some teachers, it could be very difficult because they're not trained in lab bench science. And then they're then able to train their students who get excited about this. And of course, this part here is still it's a big piece of work that we have to do too. And then they get shunted to community colleges if that's what they want to do, because they get excited about things that are going on at the community college and gain some hands-on skills. And then what happens then, what we all hope to happen, and where's my arrow? Oh, there's no arrow going down here, is to a job or universities transfer. And what we all want for our students, and Rob talked about this with some of his students, is students with careers with a living wage, but also that they have some kind of community importance and to give back to the community, who are also essential. So I think that those ideas then is to create this raw knowledge, no knowledge, and then to create the supply chain so that we can have these industries with students with, good knowledge and good technical skills. And I think that's it for me. Yes.
Nice job.
So thank you. Any questions?